server and devices. Devices can be storage devices and all type of devices. So this is, you need to note that the HCSI is not a software or a software part of the computer, but it is an hardware. So basically, it is kind of a chip that is plugged inside your motherboard, inside your computer or a server. So that chip help you connect between the computer itself or the server itself and the devices, which can be your external devices and all those devices. So, and then you have the ISC SI, which will encapsulate the SCSI command. Okay, so we spoke about that last week, and if I'm not mistaken, the last part. Okay. So when we talk about the SCSI, so you need to SCSI, yes. So you need to understand that this is all about it's kind of a protocol that will actually connect our devices to the server or to the computer. So you need to understand your computer will connect to the devices such as your hardware, not hardware, your hard drives, your scanners. Okay, so the SCSI will have a controller. It's going to have controllers, and these controllers will manage all the communication and the data transfer with different devices, so between the computer and all these other devices. And you have a certain type of architecture with the SCSI, which will allow allocating resources to all these devices that are plugged to your computer. Okay, and all the processes can happen in real time at the same time, so in a parallel. So you have parallel operation that is happening there. Okay, so computers will communicate with your storage systems through the buses, which are part of the SCSI. Okay, so you need to understand that. All right, so the SCSI, we have the SCSI initiator and target. Okay, so what is SCSI initiator and target? So the initiator will actually generate all the command description there. So we have all the command that will be generated by the initiator, and then we're going to have target. Target is where the informations are supposed to flow. Sorry guys, can you see my screen?
Yes, we can.
All right. Do you see which screen do you see? What's written on the screen? What's the title of what you see?
It's ISCSI initiating target.
Okay, perfect. All right. So the ISCSI will actually communicate. Okay, it's actually a communication system which will inherit features from the SCSI. So this is just some command that are going to happen. So we have the initiator, right, and target. So the initiator will actually be the client, which will send all the input and output requests. So all these initiator that you see in here, so they're going to send all the input and output requests, which is whatever the computer needs to do over the network. So, for example, you want to ask the storage to read or to write certain data. So this is going to be done by the initiator. And the target is actually the storage system, okay, that will respond to that request to perform that operation, okay? So once the connection is established, the targets become the primary controller of the connection, because now the data are on the target. Okay, so we have many types of ICSI initiator, which we're going to actually talk about in the coming chapter. All right, so understand that. So you have the targets that will receive the instruction that is coming from the initiator. So and then we have let's talk about so we've learned about the FCSAN and IPSAN, different protocols. So now we can assume that two sites use different network. So one is using a FCSAN and the other one is using a TCP IP, right? So how can storage devices at two sites communicate to each other? Because remember now, one site is using a different type of connection. The other one is using a different, okay? So you can converge a fiber channel and this TCP, all right? So convergence of fiber channel and TCP. So we have, when you look today, you have the Ethernet technologies. When you talk about Ethernet technologies, is when we plugging all our devices using cables for the internet. When you look even in your own home, there is a cable. Maybe it's a telecom cable, or it can be what is this other company, OpenServe and all those companies. And then that cable come in your house, and then you have your router which has an Ethernet, and then from your router now the connection will be shared in your house, right? So with Ethernet technologies and fiber channel technologies that are developing really faster, it's really we will find ourselves in an environment where we need to use different type of connection. Like for example, the IPSAN and the FCSAN needs to coexist in the same environment. All right. So when we looking at these convergence now between these technologies here, because you need to understand, you have, for example, your fiber channel, which connects to two separate fiber channel FCSAN, right, over the TCP network. So that's how we can create a convergence. So basically, we connect geographically separated fiber channels over the TCP network. So how is it gonna work? So basically, we're going to use the same IP infrastructure to create kind of a tunnel between these two channels. Okay, so this will allow the data to move from one type to another type. All right, so what's happening is that we have internet fiber channel protocols, which can also be called IFCP, which is kind of a gateway to gateway. You know, when you're using your fiber, it's all cables that are working. So we can combine these two type of connection, combine them into one system. Okay, so all right. So the internet fiber channel protocol, which is a gateway to gateway protocol that will provide your fiber channel communication, will be implemented as a end-to-end IP connection. So we have your FCP gateway here through the TCP IP connection. That's how we're going to connect to different devices in a different location. So this is the two centers that we're talking about. We have different places where we're going to have. So we have our IFCP. So when we talk about IFCP, so it's basically kind of a fiber channel communication service over an IP network. All right. So basically, this is kind of this is where what we call a convergence method, where we allow a fiber channel and the TCP or IP network to just merge and work together. Okay. All right. So the Internet Fiber Channel Protocol will allow kind of a direct connection. All right. So this can be easy to basically manage all the flow of data to avoid congestion. Okay, so we're going to have this type of internet, different type of internet, a different type of connections, but we merged them. We have one unified type, which we're going to be using for this. All right, so talking about the Internet Fiber Channel Protocol, or IFCP protocol stack. So this is, as I said, will be between the fiber channel and the TCP. Okay, which means that your IFCP can actually work with either your fiber channel or your TCP. So we have so we're gonna have maybe like the main function of this will be just to transport the fiber channel. An example I can give you is let's say you want to transfer certain data from a certain data center to a different data center through a fiber channel, and then the other center does not have a fiber channel. But with this, when we have this convergence, everything just become easy, right? So the main function of the IFCP protocol will just be to transport fiber channel frames between locally and remotely endpoints. Okay, so that's how it's going to work. So we're going to have the fiber channel. We can also have what we call a fiber channel over the internet. So that is also another method that can be used. The fiber channel over Ethernet. So this is so this is the method that will allow the transmission of the local area network, which is your LAN, basically the network that you use at your home when you plug in the computer to another one via the Ethernet. So it's going to help transmit the data from the LAN and the FCSAN data on the same Ethernet link. So this will reduce a number of devices that you need to use, the number of cables, you know, can use. So basically you have, this is the Ethernet data link frame. So when you look at this, you know, and then you have, so if you take, let's say you cut that cable, then you see inside there's many cables, like with different colors. So each one has its own purpose. So there is one that is actually designed to just transfer data that has to do with video streams or voice over the internet, voice over IP. You have the voice over IP calls, like this one is just for phone call, for calls over the internet. And then you have the block storage fiber channel over Ethernet. And then you have your service flow IP address, you know, so you have these different functions, but everything work in one Ethernet link. So one cable will help transfer data over different type of network. Okay, so having this method of fiber channel over Ethernet will help reduce the numbers of devices you need to use, the numbers of cables. So you have one cable that's has many functions. So that's one of the best option of using that. So you need to understand this is the main purpose is just to reduce the amount of cables, devices, and all that. Okay, so remember the FCOE, which is the fiber channel over the Ethernet, will allow you to both use LAN, so your regular network traffic, and your fiber channel through the same cable. All right, so the benefit of that, as I've said, fewer devices will be used. You're not going to use a lot of cables, okay? And this will also reduce power consumption and cooling requirements, okay? So this will transmit all the data from the LAN traffic or SAN traffic. Everything can travel in the same Ethernet infrastructure. Okay, and at the same time, it's going to maintain the speed in terms of the transfer of data. Okay, so there is many layers when it comes to fiber channel. So these fiber channels will have many layers, like you go from 0 to 4 here. So each layer here will have its own purpose, right? So you have these Ethernet protocol layers, and then you have these ones are the Ethernet protocol layers, and then you have your these are your fiber channel layers. Okay, so as we're going to start with networks tomorrow, we're going to talk about things such as certain concepts such as IP address. What is an IP address? The MAC address, difference between a MAC address and an IP address. So all these specification, all these things that you see here, that's why when you take your router at home, you look behind the router, you see a lot of codes there. They will tell you maybe an IP address, the MAC address. There's many information that they will give you there. And these are the things that we're talking about here in terms of how the internet is being transferred. So from different home, we can have different specifications depending on the device you're using. So when we look at these layers, this protocol stack, so we have 5 layers. So as I'm saying, from FC0 to FC4, so the fiber channel layers. So the FC0 will be what we call the FC0 here will be what we call a physical layer. Is my screen so okay? All right, so the FC0 would be the physical layer. So the FC0 will basically be your the purpose of the FC0 would just be to specify how bits are transmitted over the fiber optic, or the cables that are being used by the fiber optic. Remember when we said last time, I've asked you to actually go on Google and write speed test. And when you do that, you check the speed test of your internet at home. And we spoke about the difference between megabytes per second and megabits per second. And I told you the speed of the internet that is shown there is not megabytes per second, it's megabits. So the transfer of data over the internet is called bits. That's the unit. So this FC0 will actually be the physical layer, so the physical medium that will control how the signals are happening. So it will basically specify how bits are transmitted over the fiber optic cables. So with the cable that you have for your fiber optic, you have one layer, which is the FC0. So the FC0 will specify how the data are transmitted over the fiber optic. And then you're going to have the second one. The second one is the FC1. So the FC1 will be the encoding or decoding layer. Okay, so the FC1 will actually define how the data frames are encoded or decoded for transmission over the network. Okay, so this layer will be the one that will have a purpose to just ensure that data are reliable in terms of converting digital data into formats that are suitable for physical layer. So remember now, your physical layer, which is FC1. So your FC1 will actually need to specify how the bits are transferred. So when you look at your internet, it tells you 25 megabits per second. So that is controlled by FC1. Now, FC0, sorry, FC0. So now FC1 will be the layer that will be encoding that. So it's going to take the digital data that you have, convert it into a proper format, which will be understood by the physical layer. And the physical layer will be able to control how the data are being transferred. So, guys, I don't know if you watch even movies when there is a, like say, we always watch in movies, there's maybe a bomb that has been activated, and then they bring people who can detonate that bomb and just stop everything. They always look at the cables. They will be like, which cable, which color, and everything, because each cable will have different functions. That's how it also works when it comes to your fiber channels. So when you open it, you have different layers. So if anything is faulty, that's when you're not going to have your internet, because one of these channels is not working. Because imagine if there's a problem with the physical layer, the FC0, it means whatever is happening is not gonna transfer any data, because the FC0 will determine how bits are being transferred. So you have your FC1, which will be the encoding layer, which will decode and encode all the transmission and ensure that the data are converted. During the data transfer, we have a conversion between the digital data being converted to physical, to a format that is suitable for physical layer. And the third one will be the FC2. So the FC2 will basically be what we call the framing and flow layer, right? So this is basically the flow layer. Why do we call it the flow layer? Because it's the flow mechanism. It controls the mechanism on how the data will be transferred between devices. So the FC2 will be the frame structure and division protocol, which means that the flow control mechanism of the whole fiber channel will be controlled, will be managed by the FC2. So the FC2 will manage the data transfer between devices. It will organize the data into frames and ensure that there's a proper delivery without overloading the receiver. So if the receiver is a certain device, without transferring the data too fast and overload that receiver, the data need to be controlled in a way that the data are being transferred. So the layer that is going to control that will be the FC2. And then you have the FC3, which is another layer, which is just for general services, right? So basically, this will provide all the utilities, like what you call this, like stripping the data in such a way that, let's say you have multiple devices or you have multiple ports to your device, and you want to connect your network through these multiple ports. So the FC3 is going to help manage that you have many devices that are plugged, but it needs to control how the data are being transferred, how your connection is happening through all those devices. So that will be the purpose of the FC3. And the last one, which is the FC4, which is what we call the protocol mapping layer. So this one will just allow, will just allow different type of data to be transmitted over the FC infrastructures. So basically, this one is just going to help you in terms of if maybe there is a different type of data that are being transferred over the network, and that will be controlled by the last layer, which will make sure that so all these layers together will make sure that they provide a proper infrastructure for the fiber channel to communicate properly with devices by transferring data. Okay, so from FC0 to FC4, all these channels, all these layers will just help and ensure that there is a high speed, the data are reliable, and then we have kind of flexible storage networking. So basically the data are controlled in terms of how they are being transferred through the network. So this is very, very important. So if you understand that, so these layers are going to work together for that. Okay, so we have a few terms, or if you can call them abbreviation, that are very important that you need to see, because you see we spoke a lot about we use a lot of terms. So just to remind you, these acronyms and abbreviations, FC, when we talk about FC, is the fiber channel. I'm sure many of us are already using fiber in our home, right, for faster internet. So FC is fiber channel. FCIP will be the fiber channel over IP, and then you have your FCOE, which is with the fiber channel over Ethernet, and then you have your IFCP, which is the Internet Fiber Channel Protocol, and then you have your Internet Small Computer System Interface, which is the ISCSI, and then the last one will be the IP over Fiber Channel, which is IPFC. All right. So tomorrow we're going to I think this will be all for today. And in the next lesson, we're going to start with networks to see how this, because here we've spoke about storage. Okay, in this chapter we spoke about storages. We spoke about how the protocols, storage protocols, so how this storage will transfer the data from servers or from computers to these devices. And in the next lesson tomorrow, we're going to start now with network, how data are being transferred through your IP addresses and all the other network concepts. All right, and then we're gonna come back to most of the topics that we mentioned in this chapter for you to understand better in terms of the network and how things are going to happen. All right. Any question, guys?